Hi, Nicole. This is number 4.1 here. Number 4.1. Show that the wave function psi equals a sine kx plus b cos kx, where those letters are constants, is a solution of the one-dimensional Schrodinger equation. And there it is. There's the one-dimensional Schrodinger equation. So I'm going to stick that psi in right there and right there. I'm going to stick it in there. And then I'm going to solve for the energy. Alrighty. So that was, what was that again? H bar squared over 2m. So that was minus h bar squared over 2m times second derivative of psi with just x. Alright, so second derivative of psi with just x equals E minus V operating on psi. Okay. Now, psi is supposed to be A sine kx plus B cosine kx. So the first thing to do is to get the derivative and the second derivative of it. Then we'll be solving for the E. Not sure what to do with this V at this point, but we'll consider that when we get there. So what is the first derivative with respect to x here? First derivative would be A times k times cosine kx. It would be, so the derivative of this guy is cosine, but then you have to do the chain rule on this function right here, so the k comes out. Now over here, derivative of cosine is negative sine. So the negative, I'm going to put that right there. I'm going to have to do the chain rule on this function again. So this is going to be sine kx. What is the second derivative? Well, the second derivative is copy down the constants and then do the chain rule on this guy again. So that's going to be k squared, but the derivative of cosine is the negative sign. All right, so copy everything down with a negative sign. And now I've got a sine here. So the derivative of sine is cosine, but it's the sine of a function. So I got to do the chain rule again. So I got a cosine over here, like that. So that is the second derivative with respect to x. So I'm going to just plug that in there. So minus h bar squared over 2m times minus ak squared sine kx minus bk squared cosine kx. Everyone has to do a problem like this, you know, all these algebra steps a couple of times in their life in order to understand what people are talking about when they say wave function and Schrodinger equation, stuff like that. And now that's going to be E minus V operating on psi, which was A sine kx plus B cosine kx. Okay. I am going to factor out a negative k here. I'm going to factor out a negative k squared, actually. There's k squared here, negative, and negative. If I factor those out, then I'll be able to just remove this whole parenthetical thing from both sides. So h bar squared, negative k squared, copy down the 2m, and then what's left if I remove negative k squared? A sine kx plus b cosine kx. And this is why this thing, this psi, this wave function psi, is a solution to this equation. Because you take the derivative, you take the second derivative, and you end up with the same thing. You know, you take the second derivative of psi, and you end up with negative k squared times the same thing. It's just psi. So this whole thing, I'm going to divide on both sides, and it's just gone. All right? So minus h bar squared minus k squared over 2m equals E minus V. So I'm going to add this V on both sides here. So that's going to be, so this is negative times negative is positive. So this is going to be h bar squared k squared over 2m equals, plus V. Plus V equals the energy. And that's it. So this is the energy of this. This is the energy eigenfunction for this. This is the energy eigenvalue for this eigenfunction psi, which is a solution to this Schrodinger equation. So that's the energy. Now, how do you know that this is a solution? You know because the eigenfunction, so this E is known as the eigenfunction. It has to be a scalar, like a number, not a function, not a vector. It has to be a scalar. And these are all scalars here. So this is a constant, k is a constant, 2 is a constant, the mass of whatever particle we're talking about here, that is constant, and the potential energy. Well, see, this potential energy, we haven't been given any information of the potential energy's dependence on x, so it's safe to assume that the potential energy itself is constant. So, since all these are scalars, no vectors, no functions, and we got these scalars by plugging in this psi to the Schrodinger equation, that means that psi is a solution to this Schrodinger equation. Is it the only solution? No way, of course. Anything that you plug into this equation that gets you scalars for the eigenvalue, for the E, is also a solution to the Schrodinger equation. Which is why there's an s orbital and a p orbital and a d orbital. All those different orbital wave equations are solutions for the Schrodinger equations. I guess in those cases, in real world cases, it would be in 3 dimensions, but it works in 1 dimension too. So that's it. That's 4-1. Thank you.